In this particular question, we are provided with a binomial expression 3 plus 2x raised to the power of -4, and we need to expand it up to 4 terms. First in the increasing powers of x and then in the decreasing powers of x. After that, we also have to find the value of x for which the given expansion will be valid for each case. So let us begin with the first part. We will expand it in increasing powers of x. The given expression is 3 plus 2x raised to the power -4. Now, in order to be able to apply the binomial theorem, one of the term must be unity. So here the first term is 3 and the other term is twice x. So we have to convert one of the term to unity. Now, since we're going to expand in the increasing powers of x, so what we will do is we're going to make the term with the value 3, we're going to convert it into 1. So this could be done by factoring out 3. So when we factor out 3, so we'll be left with 1 in the first term, and the remaining second term will be twice x over 3. Also, the trick here that you can use is, since in the question is particularly asked to expand in increasing powers of x, so we make sure that in one of the terms the x is present in the numerator, such that when we expand it, it will be in the increasing powers of x. This will become evident in a moment. So let us begin. Now that we have factored out 3 from the binomial expression, now we are going to take it out of the parentheses, and this will be 3 raised to the power of -4 using the laws of exponents, and the leftover term will be 1 plus twice x over 3 raised to the power of -4. Now this is in the standard form of the binomial theorem for any index. Then we're going to expand it. So this will be 3 raised to the power of -4, the 1, which is the first term, plus nx. So our n here is -4 and x here is twice x over 3. So this is our second term, plus the third term, which will be n times n minus 1 over 2 factorial times x squared. So our n here is -4, then n minus 1, which will be -4 minus of 1, and that would give us -5 over 2 factorial times x squared, and x here is twice x over 3 squared, plus n times n minus 1, which will be -5, and -4 minus 2 will give us a -6, divided by 3 factorial times x cubed. So x cubed will be twice x over 3 raised to the power 3. Now we simplify the values. This will be 1 divided by 3 raised to the power 4 times 1. So -4 times 2 will give us -12. So we have -12x over 3. Then -4 times -5 will give us +20. So we'll have 20 over 2 factorial, which is simply 2, times 2x squared will give us 4x squared, divided by 9. Then we have -4 times -5, which will give us +20, and 20 times -6 is going to give us -120. Divided by 3 factorial, which is 3 times 2, simply 6, times twice x cubed will be 8x cubed, divided by 3 cubed, which is 27, plus the remaining terms. On further simplification, we should get 3 raised to the power 4 will be 9 times 9, which is 81, times 1 minus, so 12 over 3 is going to be 4x, plus 20 over 2 is 10, so 10 times 4 is 40, so we have 40 over 9 x squared. Then we have 120 divided by 6, which is 6 times 20 is 120, so we have 20 times 8, which will give us 160 divided by 27 x cubed, and the remaining terms, because we are asked to expand up to the first 4 terms, so we have the 4 terms here. Now you can see that the exponent of x is in the increasing order. So this is what was asked in the question, to expand in the increasing powers of x. So now that we have the expansion of 3 plus 2x raised to the power of negative 4, we also have to find out the value of x for which the expansion is going to be valid. So for this, what we do is we take the form 1 plus 2x over 3 raised to the power of negative 4. So we take this portion and we'll try to figure out the value of x for which the given expansion is going to be valid. So we have 1 plus 2 over 3x raised to the power of negative 4. So from here, the condition tells us that the absolute value of 2/3 of x must be less than 1. So we have 2/3 times the absolute value of x less than 1. Then we multiply both sides by 3 over 2, and that would give us the absolute value of x is less than 3 over 2. So this is the condition, that the absolute value of x must be less than 3 over 2. Or we can simply write that x is going to lie between negative 3 over 2 and positive 3 over 2. So this is the radius of convergence of x. So for all values of x lying between these two extreme values, the given expansion will be valid. Now let's move on to the second part of the question, where we have to expand 3 plus 2x raised to the power of negative 4. We have to expand 3 plus twice x raised to the power negative 4 in the decreasing powers of x. So here we'll follow the same route, where we have to make one of the terms equals to 1. So this time I'm going to factor out twice x. The reason will become evident in a moment. So when we factor out twice x, so I'll have 1 plus 3 over twice of x. And the whole thing is raised to the power of negative 4. Now, whenever the question asks you to expand a given binomial expression in the decreasing powers of x, we have to make sure that in one of the terms, the x is in the denominator. When it is in the increasing power, the x must be in the numerator in one of the terms. When it says we need to calculate in the decreasing power of x, then the x value should be in the denominator. So this will give us twice x raised to the power negative 4 times 1 plus 3 over 2x raised to the power negative 4. Now we apply the binomial theorem. So this term will simply become 2x 1 over 2x raised to the power of 4 times 1 plus n, which is negative 4, times x, which will be 3 over 2x, plus n times n minus 1, which will be negative 5, divided by 2 factorial times x squared, and our x squared is 3 over 2x whole squared. And the fourth term will be negative 4, which is n, times negative 5, which is n minus 1, times negative 6, which will be n minus 2, divided by 3 factorial times x cubed. So our x cubed will be 3 over 2x whole raised to the power of 3 and the rest of the remaining terms. Now we go ahead and further simplify it. So we get 1 over, so 2 raised to the power 4 is 16 times x raised to the power of 4 times 1. So we have negative 4 times 3, which is negative 12 over 2x. Then we have negative 4 times negative 5, which is positive 20. So we have plus 20 over 2 factorial, which is simply 2, times 3 squared, which will be 9, divided by 4x squared. Then we have negative 4 times negative 5, which is 20. 20 times negative 6 is 120. So we have 120 over 3 factorial, which is 6 times 3 cubed. So 3 cubed will be 27, divided by 2x cubed, which will be 8x cubed. And this would finally give us 1 over 16 x raised to the power of 4 times 1 minus, so we can factor out 12 and 2, so we have 2 times 6, 12, so this will be 6 over x. Then we have 4 times 5 is 20, so we can factor out 4 and 20, so this will be 5, and 5 times 9 is 45, so we have 45 over 2x squared. Then we factor out 120 and 6, so 6 times 20 is 120. We can further factor out how much can we factor out? We can factor out, so 20 and 8 has a common multiple 4, so 4 times 2 is 8 and 4 times 5 is 20. So 5 times 27 will be, let's find it out. So 7 times 5 will be 35. 5 times 2 is 10, and this is 135. So we have 135 over 2x cubed plus the remaining term. So this is the expansion of 3 plus 2x raised to the power negative 4 in the decreasing power of x. So now that we have found out the expansion, we'll also have to figure out what is the accepted value of x for which the given expansion is going to be valid. So we find out, so we consider 1 plus 3 over 2x raised to the power negative 4 and apply the condition that the absolute value of 3 over twice x is less than 1. And this should give us 3 over 2 times 1 over absolute value of x less than 1. We take the reciprocal on both sides, so that should give us 2 over 3 times the absolute value of x. Now when we take the reciprocal, the sign of the inequality flips. Now we multiply both sides by 3 over 2, and that should give us the absolute value of x is greater than 3 over 2. So in other words, we can say that that x must be greater than 3 by 2, or it should be less than negative 3 over 2. So the accepted value, or can say the accepted range of values for x will be all the way starting from negative infinity up to negative 3 over 2, union starting from 3 over 2 all the way up to positive infinity. So for these particular values of x, the given expansion will be valid. Let's move on to the next question. So in this question, we are given a binomial expression and it has the form 1 over 4 minus 3x squared raised to the power of 1/3. We have to expand it up to the first 4 terms and figure out the value of x for which the given expansion is going to be valid. So let us begin by first simplifying the expression 1 over 4 minus thrice x squared raised to the power of 1/3. So we can take the expression in the denominator up to the numerator. So this will be 4 minus 3x squared raised to the power of negative 1/3. As we are asked, as we have not been specified whether to expand it in increasing powers of x or in the decreasing power of x, so we will go with increasing powers of x. When it's not specified, then we take the usual route. So we have to make one of the term equals to 1, and also make sure, since we are going to expand it in the increasing power of x, so in one of the terms the x must be in the numerator. So the best way to do is factor out 4 so that the other term, which is thrice x squared, the x will be in the numerator. So let's do that. So we'll have 4 times 1 minus 3 over 4 times x squared raised to the power of negative 1/3. Then we pull out the 4 and that will give us 4 raised to the power of negative 1/3 times 1 minus 3 over 4 x squared raised to the power of negative 1/3. Now what we'll do before expanding, we'll try to find out the value of x for which the given expansion will be valid. So now that we have the simplified form, which is 1 minus, not exactly a simplified form, but the form which will help us to find out the expansion. So we take 1 minus 3 over 4 times x squared raised to the power of negative 1/3. So to find out the value of x, we have to apply the condition that the absolute value of negative 3 over 4 times x squared must be less than 1. So that would mean we have 3 over 4 times the absolute value of x squared is less than 1. Then we multiply both sides by 4/3 and that will give us the absolute value of x squared is less than 4 over 3. The absolute value of x squared is simply x squared less than 4 over 3. So we'll have x squared minus 4 over 3 less than 0. So negative 4 over 3 can be, 4 over 3 can be written as 2 divided by square root of 3 whole squared is less than 0. Then we apply the identity a squared minus b squared is equals to a minus b times a plus b. So that would give us x minus 2 over root 3 times x plus 2 over square root of 3 is less than 0. To solve this inequality, we apply that if a minus b times a plus b is less than 0, then we can say that a lies between negative b and positive b. So that would mean we have x lying between negative 2 over root 3 and positive 2 over root 3. So any values that lies between negative 2 over root 3 and 2 over root 3 is going to satisfy the expansion, which are going to perform in a moment. So this is the required value of x that we need to consider. Now we move on to the expansion part. So let's rewrite the equation, and equation the expression. So we had 4 raised to the power negative 1/3 times 1. So here I'm going to write a plus here and take the negative common. So we have 3x squared over 4 whole raised to the power of negative 1/3. And we're going to expand it, and this will be simply 4 raised to the power of negative 1/3 times n plus 1 plus, my mistake, n, which is negative 1/3 times x. So x here will be negative 3 over 4 x squared plus n, which is negative 1/3 times n minus 1, which will be simply negative 1/3 minus 1 divided by 2 factorial times x squared. So our x squared is negative 3 over 4 x squared whole squared. And the final and the fourth term, since we are asked to expand up to first 4 terms, so we have n, which is negative 1/3 times n minus 1, that will be negative 1/3 minus of 1 times negative 1/3 minus 2 divided by 3 factorial times x cubed. So that would be simply negative 3 over 4 times x squared whole raised to the power of 3 and the remaining terms. Now we simplify them, so that should give us 4 negative 1/3 times 1. So negative and a negative will become a positive, though we can factor out 3 from both the numerator and denominator. So that leaves us with x squared over 4. Now we have negative 1/3 times, and negative 1/3 minus 1 will be negative 4/3. So negative 1/3 times negative 4/3 divided by 2 factorial, which is simply 2, times negative 3 squared will be 9, x squared whole squared will be x raised to the power of 4 divided by 4 squared, which is simply 16, plus we have negative 1/3 times negative 4/3 times negative 7/3 divided by 3 factorial times negative 3 cubed will be negative 27 divided by 4 cubed, so which is 4 times 4 is 16 and 16 times 4 is 64, times x squared whole cube, so that will be 2 times 3, which is simply x raised to the power of 6 and the remaining terms. Further simplification gives us 4 raised to the power negative 1/3 times 1 plus x squared over 4. So we have negative and a negative multiply to each other, so that would become positive. So we get x raised to the power of 4 divided by 8. So you can use a calculator to multiply all the constant numbers, and that should give us 1 over 8 times x raised to the power 4. And the final and the fourth one, when you use a calculator, and that should give you 7 over 96 times x raised to the power 6. plus the remaining terms. So this is the expansion of 4 minus thrice x squared raised to the power negative 1/3, expanded up to 4 terms in the increasing powers of